Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am discussing wave mechanics, and in this chapter, this is lecture number 4. In previous lecture, I've discussed already about Heisenberg's uncertainty principle and one numerical. In this lecture also I will take one numericals and see how we compare Bohr's model, Broglie's model and Heisenberg's model. Okay, so I'll start again a second numerical. In an atom, an electron is moving with a speed of 600 meters second inverse with an accuracy of 0.005%. That means this is an error in measurement that can be delta V. That means delta V will be 0.005% of 600. Okay. Certainty with which the position of the electron can be located is blank. That means you have to calculate delta x, means you have to find out delta x in this case. Now what is given etc. along with this is Planck's constant h, that is 6.626. Even if it is not given, you have to remember these values, and as it is given in meter second, delta V is given in meter second, so we have to use MKS units, and therefore del H is equal to 6.626 times 10 to the power minus 34 joule into second. Okay, mass of electron, this you have to remember, 9.1 times 10 raised to minus 31 kilogram. Okay, and here as delta V we have to find out from this information is this one, delta V. How? That means in case of 100% accuracy, the speed is 600 meter per second. So in case of 0.005% accuracy, the speed will be, that is delta V is equal to 600 times 0.005 upon 100. Okay, and this will be roughly 0.03 meter second inverse. So delta, this is delta V. Now we know delta V, we know H, we know M, and we have formula for answers. Delta X times M delta V greater than or equal to H upon 4 pi. We have to find out delta X, so it should be subject. So delta X is equal to H upon 4 pi times 1 upon m into delta V. Substitute values of all and we have 6.626 times 10 raised to minus 34 upon 4. Pi is equal to 3.14. Mass 9.1 times 10 raised to minus 31 into 0.03. Delta V is 0.03. So here we have 10 raised to minus 34 and on denominator 10 raised to minus 31. So 6.626, we can simplify one more time. 4 times 3.14 times 9.1 times 0.03 into 10 raised to minus 3. The answer will be meter. So this is what delta x is. Okay, then you can calculate and find out. So this way the numericals can be asked based on Heisenberg's uncertainty principle and you can answer the questions. Okay. Now we will see what is the outcome of Heisenberg's uncertainty principle. So according to Heisenberg's uncertainty principle, before that we will discuss Broglie's principle because that is also in favor of Heisenberg's model. Okay, so according to Broglie's principle of dual nature, according to Broglie's principle of dual nature, when applying to a moving microscopic particle like electron, then its structure of atom would be more complicated. So we can compare this with Bohr's model. Now we know what is Bohr's model. It is already being discussed and you know very well. Once again, I will just refer it one for you that this is an atom which is having nucleus. Electron is revolving around nucleus and this is a circular path having radius r. So r is equal to 5.3 times 10 to the power minus 9 centimeter according to Bohr. So this is Bohr's model. And in Bohr's model, we know position of electron, radius of atom, then mass of electron, so momentum of electron, angular momentum of electron, and etc. So here electron is revolving around the nucleus on a circular path, which is known as radius of an atom. Therefore, R is constant. So, Bohr model is accurate model with all accurate values. Now we will see Broglie's model. So, according to Broglie, electron has dual nature. That means electron cannot move around nucleus on a circular path. Why? Because electron is a particle as well as wave. So suppose this electron is revolving around nucleus, then the path of electron would be wavy, like this. And therefore, the distance between electron and nucleus cannot be constant. It changes. Every time it is changing. That means radius is variable. So we are moving from Bohr's accurate model to inaccurate model of Broglie. Now we will see what is happening in Heisenberg's model. So according to Heisenberg's, the position of electron is uncertain. The velocity of particle is uncertain. Therefore, everything is uncertain in Heisenberg's model. So, the electron can be anywhere around nucleus like this. So, these all dots indicate the position of electron at one time. And it is always changing. This position is not constant. Every time electron is at different distance from nucleus. And this way electron is continuously moving around nucleus at different levels. The energy of electron changes, then velocity also changes, position of electron changes, but this is maybe we can say that it is a certain path or part of atom around nucleus in which the probability of finding electron in this part, the probability of finding electron is maximum. So now we are having complete uncertain model. So this shows that probability of finding electron in this area or in this space is maximum. So this shows probability of finding electron maximum. So in this area, the probability of finding electron is maximum. So here, according to Heisenberg, position of electron is uncertain, momentum of electron is uncertain, velocity of electron is uncertain. So we cannot find out anything. So how will we explain it? With probability. Instead of giving the accurate values of R, V, etc., Heisenberg realized that electron can be anywhere around nucleus, but there will be still certain space around nucleus in which possibility of finding electron is maximum. So this way, this is the area in which probability of finding electron will be maximum. So here, this is structure of atom according to Heisenberg. Okay, so this is the outcome of Heisenberg. Now we have totally uncertain structure of model. That's it in this lecture. Thank you so much.